Alright, if we're going to talk about lenses and mirrors, let's kind of start off with a little bit of a lens and mirror primer here. I mean, we already know that, y'all know the two equation. M is equal to H prime over H, and it is also equal to negative Q over P, and 1 over F equals 1 over P plus 1 over Q, where F is your focal length, P is your object distance, Q is your image distance. H prime is a height of image, H is a height of an object. The only other equation you need in any of these problems, one of the problems said something about radius, and whatever radius is equal to 2 times the focal length. So that's every equation that has to do with lenses and stuff like you're going to have to worry about. Alright, so two main types of lenses. Your convex lens, which is called converging for a reason. The reason why it's called converging, when parallel rays of light enter a convex lens, they're going to be bent towards some focal point. So there's a convex or converging lens. A diverging lens or concave lens looks like this. So this would be concave, or a diverging lens. And what happens when parallel rays of light enter a concave lens, they get refracted away from an imaginary focal point. So the light rays actually refract outward just like this. So there's what goes on those types of lenses. And one of the other things we're going to do is do lens drawings and stuff, but I was wanting to work these problems first because the lens drawing should be the easier things to learn. But really, I guess maybe it's drawing the lens diagrams is what helps me do these problems. But anyway, we're going to try and work them without doing this. In general, convex lenses, your F is going to be a positive number. Concave lenses, your F is going to be a negative number. We've talked about that. Now, if you're talking about mirror, it's reversed from each other. Now, the only thing you need to remember is this. If you're working a problem out for one of these, if you're working a problem out and both your answers end up, if your Q ends up positive and your P is also positive, what you've got are images that are formed on the opposite sides from each other. Now I'll go ahead and tell you that chances are if they're on opposite sides, they're going to be, one's going to be inverted. Now, if you work a problem and you've got, let's see if we can do this. Notice how I'm drawing this kind of lens. But it could work with the other. But if you work a problem and your P is positive and your Q comes out to a negative, that actually means, like if this is your P, your Q will also be on the same side. Once again, for a mirror, this is completely opposite from each other. If you get positive and positive on a mirror, that means the image and the object are both on the same side as each other. So anyway, all you got to remember is what a lens is, and just remember everything about mirror is exactly the opposite. Alright, that's all the basics. Let's take a look at the problems that y'all were assigned to work. And I'll try not to work them too fast. First one, number 30, and I'm going to try and draw them a little as I go because that helps me. Where must an object be placed to have a unit magnification of 1 for a converging lens